Hello everyone, today's topic is about generators, okay? So let's move into the first part about a simple AC alternating current generator, okay? So last time we talked about two rules, right? One is left-hand rule, another is right-hand rule, right? So you have to stretch out your three fingers. And if you're using the left-hand rule, the thumb means your force direction, right? Remember, it's the force direction. And second hand means first finger means the magnetic field direction. And the second finger means like the current direction, right? And if you're using the right hand rule, please remember the first thumb finger means like maybe it's a motion direction, right? And the first finger means magnetic field direction, and the third finger means the current direction. Okay, so they are inversed. Okay. So in this graph, please remember that, oh, maybe for this kind of coil, it is like generated and it is like rotating, right? So we have the force or we have the motion in the graph, right? And we also have a magnetic field. You can find here is a north pole and here is a south pole, right? So we can use in B to represent for magnetic field. So we can provide it I, okay. So last time we were discussing about the left-hand rule. It's just like we are using I, the current, and the magnetic field B to provide the the force. Okay, force on it. Okay, so this is very important. Okay. So here you can find, oh, maybe the coil is rotating, right? Coil is rotating. And you can using your left-hand rule, or maybe here, if you're more familiar with right-hand rule, you can just means here you can find this coil is moving upward, right? Okay, this coil has a upward motion, right? So your thumb means a motion direction. And then magnetic field means like you can find here is from the north to the south, right? Okay, maybe using the right hand. It's a little bit hard to represent for it, okay? Right hand and from the north to south, okay? And you'll find your second finger is just moving upward to the in part, right? So here we can say, oh, maybe here the current is just moving like this way, okay? But this is for this kind of simple alternating current generator, okay? You can find this produce a current on this way. And on the right part, you can find it produce another inverse direction current on this way, okay? So you can form a loop where you can form a current loop. Okay, you can find here as a current running in the coil. Okay, this is very important for you to understanding for the alternating current generator. Okay, so this is for this part. Okay, so we're just using this to like build a motor or a generator or another kind of any kind of using the like the current. Sorry, using the motion and the magnetic field to provide the current. Okay, very important. Okay. So here is an example like if you're using the alternating current generator, and you'll find that when you're turning the coil, you'll find there are different directions. You can find in the first figure, you can find the coil is just upward, like this way, okay, upward. And this way, and after it rotate, it becomes a horizontal part, okay. And then it becomes a vertical part, horizontal, vertical, okay. So how will it make a effect, or how the position will make an effect on the current in the generator? Maybe we can set like here, you will find that this is a coil, right? And here we have maybe positive and negative charge. And you can find here, maybe if you're rotating like this way, and this is the north pole and south pole like here, okay. So you can find at this very, very small period or very small second, you can find, oh, the motion direction is totally perpendicular to the like magnetic field direction, right? So based on the left-hand rule, you can find they are perpendicular to each other. So at this time, you have the biggest current. Okay, you have the biggest current. So you can find maybe here in the first places, you can find there's one right here. This represented for the maximum forward current, right? Because they are perpendicular to each other. So once you're rotating and make the coil to like here, okay, and you will find that motion direction just parallel with the magnetic field direction. So based on the rule, like they're perpendicular to each other. So we have to set, oh, maybe here there's no current inside of this. Like here and here, there are 2 points, there's no direction. Okay. So finally, it will form like a sine function, like this graph. Okay. So we can say this is for alternating current generator, and it can provide alternating current inside of this. Okay. So for DC generator, direct current generator, just using like different card of like here DC generator, and we have different coil inside of this. So once you rotate, maybe you can set, oh, here the different coil can provide a very like like the same direction current. Okay, so maybe here is just like if you have a sine function like this way, there's a sine function like this way, and you just erase like the purple part. Okay, so you only left this part, so we can say it formed like a direct current. Okay, so maybe in the later we will learn about this. So today we don't need to understand this for very much. Okay, so this is called rectifier. We can use in the diode we said before to limit the inverse direction current. Okay, so we can only have one path of direction. Okay, this is for rectifier. Okay, so please just doing this exercise, please, and trying to understand how it will rotate and how will it make an effect on the current. Okay. Okay, so let's back to this question. Okay, so it said which change would make the coil turn in the opposite direction. Okay, so we said before that like motion direction and the current direction and the magnetic field direction, they're like perpendicular to each other. So if you want to inverse one direction, so you have to inverse another any kind of parameters. Like if you want to inverse the current direction, or sorry, the turning direction, you have to inverse the magnetic field direction, or you can say, oh, maybe here you can just reversing the uh current direction. Okay, so here like decreasing we cannot use this, right? To just decreasing, just like decrease the magnitude, we cannot change this direction, right? And secondly, it increases the number of turns in the coil. Also cannot choose this one because it can make it have a faster rotation, right? And C, reversing both the direction of the current and the coil and the poles of the magnet, right? So C cannot be choose, right? So it's just like maybe here we have like this two direction, maybe here is for current and here is for magnetic field. And maybe we have like this fourth direction. So if you reverse both, like here it's become B and becomes I, here still the fourth direction. If you only reverse, maybe, oh, sorry for that. Okay, like this one. Okay, so if you only reverse one direction like this one, the force must reverse. Maybe you can use your hand to represent for it. Like just raise up your hand just to using your three fingers to represent for this shape. You can find we can only like inverse by inverse just one parameter. So we cannot inverse both. Okay, so C cannot choose. So D reversing only the direction of the coil, current in the coil. Okay, so we can choose this part. Okay, this is useful and helpful. Okay, so we finally we choose D. And another exercise like here, which diagram represents for the voltage output of a simple AC generator? Okay, so we have said before, like if you are a alternating current generator, right? So you are just like a sine function, right? So here is for the AC generator, like this way. So we finally choosing B. Okay, so for A, you can find all the sine functions are above the graph. And maybe C, you can find there's maybe after rectifier, or maybe you can say, oh, maybe here is just a very like we remove this part, right? Because then we just making like a diode and adding other components to make it rectifier, right? So maybe D you can find is a very direct current, right? It has a same voltage at all the same time, right? So we cannot choose D. Finally, we choose B. Okay. So this is for today's lesson. So see you next time. Bye.